And this is Unit 9, Lesson 4. So we're moving on to our third shape in the conic sections unit. These are hyperbolas. And just as a reminder, these are the ones where you have two cones kind of stacked right on top of each other, and you just put a vertical slice right down the middle. So it kind of looks like a right side up parabola and then an upside down parabola. So it's two different shapes that you're always going to see with these. So up top, just like we did with ellipses, quick formal definition. If that means nothing to you, totally fine. But here's the actual definition. Set of points to the difference of the distances from any point remains constant. So you could do this with any different point. So like you could pick this point right here, and then it goes this point to this point. So see, look, it's making a nice little parallelogram there. So what they're saying is this distance minus this distance is going to be the same no matter where you're at in that hyperbola. Okay, so we could do the same thing like even right here, really close to one of them. They're saying that this distance minus this distance is going to be the same as this distance minus this distance, etc. So let's look at our different types. We've got a horizontal hyperbola, and what that means is you've got one piece on the left, one piece on the right, versus a vertical hyperbola where you've got one piece on the top, one piece on the bottom. So some definitions. The center, HK, is the midpoint of the, now remember, we're not really talking about foci, so we're just going to say the middle of the vertices, because that ends up being the exact same thing. The asymptotes, we've done asymptotes before. We've seen horizontal asymptotes when we did our exponential functions in Unit 7. We also saw vertical asymptotes when we did our logarithmic graphs in Unit 7. So now these ones have diagonal asymptotes. So diagonal lines that guide the curves, meaning they tell you how wide or how narrow these curves are supposed to be. So we've got two dotted lines running right through here. Vertices, or turning points, are A, units away from the center, just like we had with ellipses. Covertices are B, units away from the center, and we are ignoring this information about foci. All right, so let's label some pieces on here. So each one of these has a center. So there's a center right here, a center right here. They have vertices. The vertices are the part that like actually go through the hyperbola. So this is a vertex here, this is a vertex here. So this is the vertex and this is the vertex with these ones. The covertices are B units away from the center. So the covertices with this one go up and down. It's like this is a covertex and this is a covertex. Or with the vertical ones, this is a covertex and this is a covertex. So notice like these 4 points are still found the exact same way that you would with the ellipse, but the ellipse, you would just connect the 4 dots and make a shape out of it. With the hyperbola, these 4 points create this little box, and the box helps you know where these diagonal lines are going to go because they end up going through the corner of the box. And then what the diagonal lines do is tell you how to guide your curve, how wide or how narrow. So once you have these dotted lines in place, you know this curve is just going to go until it hits the vertex, and then kind of just use these as a guided line, just like the exponential functions use the horizontal asymptote as a guiding line. All right, so just some definitions here. We're going to write our standard form. So centering at HK, notice these two, these are under horizontal, these are under vertical right here. So the standard form for a horizontal hyperbola is this. Okay, so look at this, almost identical to the ellipse equation, except ellipse has addition, hyperbolas have subtraction. All right, so now if it is a vertical hyperbola, the y goes first, and the x goes second. And that order really does matter here because it's subtraction. So it does matter what order you're subtracting in. Now notice the vertices are always A units away. The covertices are always B units away. With ellipses, the vertices were always the longer ones. That is not necessarily true here. It might be true, but it's not a rule. With ellipses, the covertices were always the shorter ones. Again, that might happen, but it's not necessarily the rule. The vertices are the ones that are actually touching the hyperbola. So even if this is a shorter distance, these are the vertices, and then with vertical, these are the vertices. They actually touch the hyperbola. The covertices do not. They are just used to make this box. All right, we are not going to do equations of asymptotes. The foci, the asymptotes, get things really complicated. Like I mentioned with ellipses, we're going to save some of those things for pre-calc or beyond. All right, we're just kind of doing an intro to hyperbola since you've never seen them before. So here's our step-by-step. I am going to put our first example right underneath so you can follow along with that step-by-step. So we're going to do example number 1. All right, so step number 1, graph the equation in standard form. So look at this. This is standard form. Matches perfectly. Don't have to do anything. Graph the center, h comma k. Okay, so our center with this one, x squared, y squared, that means the center is just 0, 0. So just like ellipses, just like circles, we're just going to put a little mark right here, represent where the center would be. Next step, graph the vertices. So you use the first denominator, a. This is very important. It's the first denominator, not necessarily the biggest. So this one, it isn't the biggest. We have a squared is 4. That means that a is 2. We're always taking those square roots. And this goes with the x. Okay, if this goes with the x, that means we are going left and right 2 units from the center. So we go left and right 2 units from the center. We're gonna have a point right there, we're gonna have a point right there. Those are the vertices, which means the hyperbola actually touches those points. That means it's a horizontal hyperbola. We'll have one going right here, one going right here. But in order to know if these are kind of narrow, like if they look like this, or if they're like big and wide like this, we need the asymptotes. In order to form the asymptotes, we need that little dotted box. And in order to make the box, we need co-vertices as well. Okay, so my vertices, I can write down these points, -2, 0, and +2, 0. 2 units in each direction. My co-vertices, I look at the second denominator, again, not necessarily the smallest. So my second denominator is b squared. That means that b is 3, and because this is under the y goes up and down. That means we're going 3 units up and down from the center. So up 3 units, down 3 units. Okay, so now here is the way that the graph works. This is up 3 and down 3. So this was 0, 3 and 0, -3. We are not doing foci. We are not doing equations of asymptotes. I'm just going to show you guys how these work. So we use these 4 points to make this little box. Okay, so that's going to happen every time. Instead of making an ellipse out of it, we make a box. Then we use the corners of the box to draw in our dotted lines, like this. And then once we have those in place, we know exactly how wide our hyperbola will be. So we guide right along these lines, turn and hit the vertex, go back the other direction, and then repeat the exact same thing on the right-hand side. Use those as a boundary, use those as a guide, hit the vertex, and go off the other side. So that is our very first hyperbola. Okay, they are not bad once you get used to it, I promise. So let's go down to the bottom of this page. We're gonna do number 4. Switch up the center on you. So you've got your step-by-step on the previous page. I'm gonna just keep talking about that step-by-step process. Graph in standard form. It already is in standard form. Graph the center HK. This one's tricky because the y is first. Even though the y is first, this is still the y coordinate, this is still the x coordinate, and when you're writing an ordered pair, the x coordinate has to go first. So x plus 1 means your center has -1. Y minus 3 means your center is a +3. So I'll plot that first. We have -1, +3, just put a little mark right there for the center. The vertices, remember, always come from the first denominator. Whether it's bigger or smaller, doesn't matter. It's always just the first denominator. So a squared is 36. That means that a is 6. And then from here, we can determine whether we're going left and right or up and down. This one, the 36 is under the y. Y goes up and down. So that means our vertices are 6 units up and down from the center. All right, so we go 2, 4, 6 right here. And we can write down that ordered pair. That point is -1, 9. And then again from the center, we can go down 2, 4, 6. That point is -1, -3. Co-vertices. Co-vertices use the second denominator. Bigger or smaller, doesn't matter. If b squared is 9, that means that b is 3. And because the 9 is under the x, x goes left and right. So we go 3 units left and right. So left, 1, 2, 3. That ordered pair is -4, +3. And then back to the center, our other covertex is 3 units to the right. That is 2, 3. None of this, none of this. So remember our pattern here? The center shares the x value with the vertices for this one, shares the y value with the covertices, but it always shares 1, either x or y with the vertices and the covertices. Okay, and then another thing I want to point out, 6 units up and down, we go from 3 up 6 to 9. We go from 3 down 6 to -3. And then b is 3, we go from -1 to the left 3 to -4. And then from -1 to the right 3 to 2. So you can see it from the graph, but you can also just kind of do a little addition. All right, we are going to make our little box here. Okay, so we use those points to make a box. We use the box to draw the asymptotes. And then this one, y is first, so these are the vertices. The vertices are the top and bottom ones. So we use this as a guide. Make sure you actually hit each vertex, and our graph looks like this. Okay, so we've seen a horizontal hyperbola, we've seen a vertical hyperbola. Let's look on the next page. Okay, so we're gonna look at number 6. The first step is to make sure things are written in standard form. Here we have yet another example where we have to complete the square. That'll pop up with every type of equation that we're gonna graph. Okay, so here we have to complete the square. We can gather up our x stuff together. So x and 10x, x squared and 10x. And then our y stuff is a -9y squared, and the 16, the constant, is already over on the right-hand side. So we start by completing the square. We group up this x stuff. We take this 10 from the middle. First thing we do is we cut it in half. That's a terrible 5. There we go. And after we cut it in half, we square it, which gives us 25. So that 25 gets added to both sides of the equation. Okay, so this right here, we've seen this format enough times before. It's now called a perfect trinomial, which can factor down into this form. We're looking for what multiplies to 25 and adds to 10, and that would be 5 and 5. So x plus 5, we can write it like that. Minus 9y squared equals 9. And finally, just like ellipses, the hyperbola also has a 1 always on this side. So we divide it out. So this is x plus 5 squared over 9 minus just a y squared equals 1. So that is the standard form for the hyperbola. Let's get all our info over on the right and we can start our graph. So our center, x coordinate first, x plus 5 means it's a -5. Y squared means it's a 0. So I can start by plotting that, just a little mark right there, -5, 0. Then I look at my first denominator, which is a 9. So that means that a squared is equal to 9. That also tells us that a is 3. And this is associated with the x. It's under the x, which means that is moving left and right. So our vertices go to the left 3 units. That point is -8, 0. We also can go to the right 3 units. That point is -2, 0. Then our covertices, we look at the second denominator, which is technically a 1. Okay, so our second denominator is technically a 1. That means that b is equal to 1. And because it's under the y, that means we're going 1 unit up and down from the center. So 1 unit up, that is the point -5, 1. And then from the center, we're going 1 unit down, and that is the point -5, 1. No foci, no asymptotes. Just finish off this graph and we'll be done. So dotted lines here make a little box. We use the corners of that box to sketch in our diagonal asymptotes. And finally, the x is first, the 9 are our vertices. So these two were our vertices, which means the parabola very narrowly opens up to the left and to the right like this. So use those as boundary lines. Make sure you hit that vertex before you go back in the other direction.